Hello everybody, welcome to this video on writing ionic equations. Now for those of you who have read up, alright, you would know that an ionic equation basically shows what is actually going on in a chemical reaction. Now if you look at the two diagrams I have here, alright, one of them, okay, I'm showing a solution of lead 2 nitrate as well as a solution of potassium iodide. Now, if you recall your assignment 3, alright, this is what you did in assignment 3, right? You mixed a lead 2 nitrate solution with potassium iodide solution to get lead 2 iodide. Alright, and that's what we see here in this overall reaction. Right? We're mixing lead 2 nitrate with potassium iodide to give you the precipitate lead 2 iodide and solution potassium nitrate. Now, how do we write the ionic equation for this reaction? Now, for any ionic equation, alright, from the chemical equation, the first thing you have to do, alright, is to split up all the aqueous compounds that you see into their corresponding ions. I repeat, first you've got to look at all the aqueous compounds you see in both the reactants and the products and split them into their respective ions. So how do we do that? Let's look at lead 2 nitrate first. Now lead 2 nitrate, when it's in the solution, as you can see in the diagram, it splits up into Pb2 plus AQ plus, don't forget, 1, 2, right? So 2 nitrate ions plus, what else? Here we've got potassium iodide in the aqueous state, so that will be split up as well to give you 2 potassium ions and 2 iodide ions. So that's it for the reactants. Now, what about the products formed? For the products formed, okay, we can see that here it is lead iodide being formed. Now, this is a solid compound. Therefore, we will not split it up because it is not in the aqueous state. Alright, it does not split apart in solution. Therefore, we let it remain as a solid. Next, we look at potassium nitrate. Alright, we see here it is an aqueous solution. Therefore, it will also split up in water. And this will give you 2K plus in aqueous solution and 2 nitrate ions aqueous as well. Now, before we go any further, I'm going to introduce to you the concept of spectator ions. Now, what are spectator ions? Let's think about it. Now, in any kind of match, let's say a football match, you always see a lot of spectators sitting by the sides, isn't it? Now, regardless of whoever is sitting by the sides as spectators, it does not affect the outcome of the match that you are watching. I don't care whether it is 10 spectators or whether the spectators are the Sultan of Brunei or Prime Minister Lee. Whoever the spectators are, they will not affect the outcome of the match. Now, how does that apply to writing ionic equations? Let's take a look at the next slide. Now, remember our total ionic equation is given here. Now, remember we said spectators do not affect the outcome of the match. Now, which are the spectator ions here? Spectator ions are the ions that remain unchanged before and after the chemical reaction. For example, in this case, let's look at the products in purple. We've got Pb2+, NO3-, K+, and I-. Now let's look at the products in green. Now, does PbI2 appear in the purple region? It doesn't. But K+ does, and so does NO3-. Now, since K+ appears both in the products and the reactants, we can cancel it out because it is a spectator ion. Before and after the match, it remains the same. Right? Before and after the reaction remains the same. Now let's take a look at nitrate. Now we see nitrate appearing in the green region, alright, the product region. We also see it appearing in the purple region, alright, which is the reactants. Therefore, they can also be cancelled out. So what is the net ionic equation? It is simply Pb2 plus Aq plus 2I minus Aq to give you Pbi2 solid. This is your net ionic equation. Alright, now let's take a look at another example. Now in this case, we have an acid-base reaction. Alright, this is a neutralization reaction, which you have been doing in your titrations, right, in semester 1. Now let's try writing out the ionic equation. Now, firstly, we have to identify which are the aqueous compounds in the reactants and the products. Now we see here sulfuric acid is an aqueous compound. We see sodium hydroxide is an aqueous compound. We see sodium sulfate is an aqueous compound. Excuse me. Now let's split up these aqueous compounds into their respective ions. Now let's take a look at H2SO4 first. Now H2SO4 was split up into H plus aqueous and SO4 2 minus aqueous. Now remember, this is H2SO4. Therefore, it will release 2 H plus ions. Next, we look at sodium hydroxide. Now for sodium hydroxide, it releases Na plus and OH minus ions. Now remember, we had the stoichiometric coefficient 2 in front. Therefore, it will release 2 sodium ions and 2 hydroxide ions. Now this are how the reactant molecule or reactants split up. Now let's look at the products. Now for the products, sodium sulfate is an aqueous compound. Therefore, we will split it up into sodium and sulfate. Remember, sodium sulfate is Na2. Therefore, we will have 2 sodium ions. Next, now, for water, it is liquid. Therefore, it will not split up, and we will just copy that down. There are 2 water molecules, right? State symbol, liquid. So with this total ionic equation that we have just constructed, let us now look at which are the spectator ions. Let's go one by one. Now, let's first look at H+. H+ appears in the reactant side, the purple region, but there is no H+ found in the green region. Right? Therefore, it is not a spectator ion. Sulfate, we see it in the purple region, which are the reactants. We also see it in the product region, which is the green region. Therefore, since the sulfate ion remains unchanged, we can cancel it out. Next, let's look at the sodium ions. Now, sodium ions appear here in the purple region. They also appear here in the green region. Therefore, it is a spectator ion. It can also be cancelled out. Lastly, let's look at the hydroxide ions. Now, the hydroxide ions appear in the purple region, alright, the reactants, but not in the products. Therefore, it is not a spectator ion. So the net ionic equation that we can form from this total ionic equation is 2H plus AQ plus 2OH minus AQ to give you 2 water molecules. Now, this of course can be further simplified because they all have a common stoichiometric coefficient. Therefore, that can be simplified to just give you H plus AQ plus OH minus AQ to give you H2O liquid. And therefore, this is the net ionic equation for the reaction between sulfuric acid and sodium hydroxide. So let's now recount the steps that are required for writing an ionic equation. Firstly, we write out the chemical equation. Secondly, we split up all the aqueous compounds in both the reactants and products. Lastly, we cancel out all the spectator ions. And voila, you should get your ionic equation. And that's all for this video. I hope it has been useful in helping you learn about how to write an ionic equation.